Hello everyone. Today we will be covering some topics from Chapter 3 Machines from the ICSE syllabus Grade 10. Let's get started. First, let's see what are machines. Machines help us to perform daily activities in a better, efficient way. There are so many examples from our daily life. One example is that it is difficult to shift a heavy block by pushing it, but it is easier to shift by using a crowbar. Another example is that it is difficult to pull up a bucket of water directly from a well, but with the help of a pulley, we can lift up easily the bucket of water from the well. The examples of simple machines we are using daily lives are wrench, pulley, crowbar, etc. Let's study some functions and uses of simple machines. There are four functions and uses. The first one is in lifting a heavy load by applying the less effort, that is, it acts as a force multiplier. The example is given on the right side. You can see a picture which shows a jack. That jack is used to lift the car or a heavy vehicle or heavy load. Okay, so here you can see a jack is used to lift up a car. That is one example. Another example, a spade used to turn the soil, and other examples are pulleys are used to lift a heavy load. In all these examples, the effort is much less than the load. In the given figure, in the jack we are applying the force that is called the effort, and that is very small. But we are able to lift up the heavy car. That means the heavy load. Okay, so here we applied a small amount of force, or we applied a small effort or less effort, but we are able to lift up that heavy car. Therefore, we can say the machine here, the jack, act as a force multiplier. The second point is in changing the point of application of effort to a convenient point. Example, the rear wheel of the cycle. You can see on the right side, the rear wheel. This is the rear wheel on the cycle, and it is rotated with the help of the chain. Here a chain is there, and here is the pedal. So this rear wheel is able to rotate with the help of a chain joined to a toothed wheel by applying the effort on the pedal attached to it. So here we want to rotate this rear wheel, and where we are applying the force or effort on the pedal. We are applying the force on the pedal, and we are able to rotate the rear wheel. Here we can change the point of application of effort is the pedal, and we are able to rotate the wheel. That means we can change the point of application of effort to a convenient point. Third point, in changing the direction of effort to a convenient point. That means here the direction we have to change. Direction. The second point, hope you understand, we are changing the point of application to a convenient point. The third point is changing direction of effort to a convenient direction. Example, in this figure you can see two kids, one boy and one girl. They are standing on near to the well, and that girl is lifting up the water from the well. So in order to lift up the water from the well, the effort has to be applied upwards. Here you can see the effort direction. Here we need to lift up in the upward direction. But by using this pulley, that is a simple machine, that is one of the machine, So by using this pulley, see, we can change the direction of effort to a convenient direction. Actually, in order to lift up, we need to apply force in the upward direction. But it is difficult to lift up upwards. But with the help of a pulley, change the direction downwards, then it is easier to lift up a bucket of water. So the third point is changing the direction of effort. That means from upward to a convenient direction, that is downward direction. And the fourth point is for obtaining a gain in speed, that is a greater moment of load by a smaller moment of effort. That means the effort moment is smaller, but we can gain in speed. Example is a pair of scissors. You can see here on the right side a pair of scissors cutting a cloth. So its blade moves longer on the cloth. So here is the point where we are applying the effort, and this is the part it cuts the cloth, and or we can say this is the blades. It moves longer, and here we are applying small movements with our hands or small effort, but we are able to cut the long cloth. That means its handles move a little, but the blades moves longer on the cloth. Hope you understand the fourth point. Next, we can study some technical terms related to a machine. The first one is load. Before that, we need to study the definition of a machine. So machine we can define as it is a device by which we can either overcome a large resistive force or load at some point by applying a small force or effort at a convenient point and in a desired direction, or by which we can obtain a gain in speed. So here in all these figures you can see we are applying a small effort. Okay, but we are able to overcome the load or resistive force. Okay, so we can say a machine, it is a device by which we can either overcome a large resistive force or load at some point by applying a small force or effort at a convenient point and in a desired direction, or by which we can obtain a gain in speed. Here you study the functions. It acts as a force multiplier. We can change the point of application of effort to convenient point, change the direction of effort to a convenient direction, and the last one is gain in speed. So hope you understand what is machine. Next, technical terms related to a machine. The first one is load. Load is also called resistive or opposing force. So load means the resistive or opposing force to overcome by a machine. That is called a load, denoted by capital L. The next one is effort. Effort means the force we are applied on the machine. The force applied on the machine to overcome the load is called effort E. The third point is mechanical advantage. Mechanical advantage is a ratio of the load to the effort. It is a ratio of the load to the effort. So let's write the equation. Mechanical advantage Ma equal to load denoted by L divided by effort represented by capital E. So therefore mechanical advantage is a ratio of load to the effort. And while using a machine to overcome the load, the effort needed is actually less. The force we are applying is less than the load. Okay. So machine has this mechanical advantage greater than 1, while if it needs effort greater than the load, it has mechanical advantage less than 1. And a machine has mechanical advantage equal to 1 if the effort is equal to the load. Therefore, we can say mechanical advantage can have three values. Mechanical advantage can be greater than 1. Greater than 1 means less effort needed. Effort is less than the load. Then it acts as a force multiplier. The next value it can have is mechanical advantage can be less than 1. Less than 1 means effort is greater than the load. That means it acts as gain in speed. It can use as gain in speed. And mechanical advantage can be equal to 1. That means it can use to change the direction of effort to a convenient point. So these are the three possible values for mechanical advantage. Mechanical advantage greater than 1, then load greater than the effort, then it can act as a force multiplier. Then if the effort is greater than the load, then the value of mechanical advantage will be less than 1. Then it can use as gain in speed. Then if the load and effort both are equal, mechanical advantage equal to 1, then we can use to change in direction of effort as there is no gain in force or speed. These are the three possible values for mechanical advantage. Mechanical advantage has no unit because load is force, its unit is Newton, and effort is also the force, its unit is Newton. Both get cancelled, therefore no unit. Mechanical advantage has no unit. Next term we have to study is velocity ratio. Velocity ratio, it is a ratio of velocity of effort. It is a ratio of velocity of effort to the velocity of load. Let's write it mathematically. So this is the equation for velocity ratio. Velocity of effort denoted by VE to velocity of load denoted by VL. If DL and DE are the distances moved in the same time t by the load and effort, then velocity of load VL we can write as dl by t. Velocity equation is displacement by time. Therefore, the velocity of load we can write as displacement of load by time. The same way, velocity of effort VE is displacement of effort by time. Therefore, velocity ratio VR equal to VE by VL. VE is dE by T divided by VL is dL by T. As dL by T is in the denominator, we can take the reciprocal and multiply. Therefore, dE by T into T by dL. Both T get cancelled. Therefore, velocity ratio VR equal to dE by dL. Once again, we can write VR equal to dE by dL. So what we can conclude from this equation? VR equal to dE by dL. Thus, the velocity ratio is defined as the ratio of displacement of effort to displacement of load. Velocity ratio can be defined as displacement of effort to displacement of load. Here, velocity ratio can have three possible values like mechanical advantage. If velocity ratio is greater than 1, that means it can act as a force multiplier. These are the three possible values for velocity ratio. First, it can be greater than 1. That means dE greater than dL. It acts as force multiplier. The second value VR can be less than 1. Less than 1 means dL greater than dE. That means it can use as gain in speed. The third point, velocity ratio can be equal to 1. That means dE and dL both are equal. It can use to change the direction of effort. Like mechanical advantage, velocity ratio also has three values. Here mechanical advantage greater than 1 means force multiplier. Velocity ratio greater than 1 means force multiplier. MA less than 1, VR less than 1. Then in both cases it is gain in speed. Then MA equal to 1 and VR equal to 1 means in both cases it can use to change in direction of effort. Hope you understand. The next terms related to machine is work input. Work input means the work done on the machine by the effort is called work input. This is the fifth term related to machine, work input. Work input means work done on the machine by the effort. So therefore we can write work input equal to work done by the effort. So this is work input. The next term is work output. Work output means work done by the machine on the load. The work done by the machine on the load. Therefore, work output we can write as work done on the load. So work input is work done by the effort. Work output is work done on the load. The last term which is very important, that is efficiency. Efficiency is denoted by eta. And It is a ratio of work output to work input. So let's write the equation eta equal to work output by work input. And efficiency is usually expressed as a percentage. So we have to write work output by work input into 100%. So this is a required expression for the efficiency eta equal to work output by work input into 100%, and it also has no unit because it is the ratio of similar quantities, that is work output and work input. So therefore it also has no unit. Hope you understand the few topics from the chapter machine. Remaining topics we can study later.